Hello, everyone. Welcome to today's webcast entitled New Technology Requires a New Approach to Resiliency, presented by Quorum and featuring Forrester. My name is Darren Pendergraft, and I'm going to be your host today. And it is my great pleasure to introduce our two guest speakers. Sophia Vargas is a leading authority on data center transformation, cloud strategy, and hybrid infrastructure architectures, all with the global goal of enhancing customer experience. I love that. It's all about the customer. Her specialties include infrastructure sourcing models, data center economics, cloud adoption, cloud economics, cloud interconnections, sustainable technologies, and customer use cases across these topics. So welcome, Sophia. Our second speaker today is Gabe Gambill, Vice President of Technical and Product Operations at Quorum. Gabe has been working in IT for over 20 years, with the last 10 in leadership positions. He specializes in full IT and disaster recovery services for financial institutions across the US and abroad. For the last 6 years, Gabe has been with Quorum in several roles, from operations, manufacturing, and technical support. And he was most recently responsible for successfully expanding the operations in Europe and to the rest of the world. So welcome to both of our guest speakers. Before we move to our first part of the presentation, I do want to take a minute and just give you a little bit of housekeeping. So today's webcast is being recorded. All registrants will receive a link to the recording. So if you want to go back and share this with your colleagues, you're free to do so. Please submit any questions you have. We're not going to take live questions during the presentation, but there is a questions tab inside the console, and you can type your questions in. And it's our intention to leave time at the end of the presentation, and we'll try to get to as many questions as we can. And finally, if we don't actually get to your question during the call, I will do my best to capture all of these questions and send an email to the email that you registered with to try to get you the questions, to try to get you answers to the questions you asked. It just really all kind of depends on timing, but we'll try to address as many as we can at the end. All right, so with that, it is my absolute pleasure to welcome Sophia Vargas, and I'll turn the presentation over to you, Sophia.
Thank you for the introduction, Darren. I'm happy to be here and share some of the insights that I've been gathering over the years across this topic. So as Darren mentioned, my focus at Forrester is all around enterprise data center strategy. I'm particularly interested in understanding how the strategy has been evolving to meet new kinds of demands imparted by the business. So the agenda that I prepared today will walk through how those demands are shifting in the face of digital transformation, how that's predicating interest in new kinds of technologies, but how those technologies are disrupting the natural order of things, how businesses have traditionally approached topics like disaster recovery and resiliency, and understanding how these strategies need to adapt in order to support modern demands. So the first order of business is understanding how the business is changing this strategy. And everything is coming around this topic of digital transformation. And if you've attended any conference, any vendor session, digital transformation is a popular term. It might have slightly different interpretations depending on who's presenting. At Forrester, we like to narrow this down to understanding the transformation required to become a digital business, to engage and serve your customers through digital services. And your customers are really at the center of this as you're trying to drive and create new kinds of experiences that will compel them to stay loyal to your services and your brand. But fundamentally, digital requires that these services be delivered and executed via technology. So fundamentally, this focus on digital transformation is increasing the number of services that organizations need to support, requiring more capacity, more kinds of infrastructure capacity. And on top of this, you're not the only organization going through this transformation. Every business is trying to create new kinds of compelling services for their customers, meaning that those same customers have higher demands, higher expectations on when things are available, how they are available, and the kind of performance and experience from those individual services. Taking a look inside the data center resources today, we definitely see an overarching trend to reduce the amount of owned infrastructure and owned data centers. This has been a trend happening for the last decade, but it's potentially slower than some might have you believe. But I see it as part of a broader strategic shift as well. It's not just that organizations aren't building data centers at the same pace, but they're looking at how can they leverage other kinds of sourcing solutions effectively, and what does that mean for understanding how they can strategically let go of services. You're a retail organization. You're not in the business of running a data center. So do you need to be owning and managing the infrastructure down to the facility level? Potentially not. That same argument can be applied to co-location, as well as starting to leverage SaaS solutions and infrastructure as a service to augment your portfolio. And we are seeing active interest to continue to adopt and expand usage of cloud, but note that it's still a relatively small part of the enterprise infrastructure environment, especially for those organizations that have been around for a few decades. The other side of this view is following the increase of cloud adoption. And at Forrester, we track cloud adoption across three prominent deployment models. Public cloud, meaning the likes of AWS or Azure. Hosted private, meaning that a managed service provider is owning and managing the infrastructure stack, and the customer comes in at the OS or the VM level, similar to what they would experience on a public cloud, but this environment is in fact dedicated for them, potentially with a little bit more customization depending on their individual requirements. Internal private cloud indicates a model where the customer owns and deploys the cloud from the physical infrastructure up through the virtualization and automation layer. Initially, we did see a lot of interest and investment in private clouds. A lot of organizations viewed this as the progression of what on-premise infrastructure should become. Recognizing the public cloud as being incredibly successful to deliver a highly scalable, automated, efficient environment, and how can they emanate those same qualities within their own infrastructure environment. This, however, is quite a daunting task from both an investment side as well as investing in the skills required to implement it. So a lot of organizations are realizing they weren't moving fast enough to keep up with this competitive landscape, and have increasingly started to look at public cloud services as a way to increase the velocity of their modernization and transformation efforts. Additionally, public cloud is not only valued as a fast and agile service, which all of these cloud deployment types could be perceived at, but public cloud also is coming with an entire ecosystem of partners on AWS's marketplace, all of these value-added capabilities that AWS continues to launch in their own platform, as well as provide access in their technology partner ecosystem, meaning that it's just a much broader set of capabilities that an individual could provide in-house. Now, putting this in context with the last side, we don't see everything moving to public cloud immediately. Depends on the individual organization, but we do see an increased interest to leverage cloud as much as possible and where it can really start adding value to your portfolio. And at the core of any transformation, you have to step back and recognize, in order to be successful in this, it's all around changing the way that you do business and the way that your employees understand how you should be doing business. And that cultural realignment tends to be the linchpin on the success of initiatives like this. It's hard to convince individuals in your organization that they need to change their thinking. They need to change the way they're doing things. So in order to be successful, we find organizations have to find a common goal that everyone can work toward and understand why they're changing what they're doing in order to accomplish this. And we see that goal best centered around the customer. After all, this is around creating new kinds of experiences for the individual customer and prioritizing that experience overall. This also means investing in tangential solutions that can bolster this capability, say increase analytics and insights to improve your knowledge of both the customer as well as your operational capabilities. Being able to accelerate your application lifecycle and delivery mechanisms, looking at new kinds of processes, say DevOps and self-service tools that can increase your developer productivity as well as your speed to market. And a topic that we've been talking about for ages across the infrastructure environment, trying to reduce the amount of silos and increase collaboration across teams. We've seen this happen in the infrastructure group, especially with the onset of hyperconverged systems and public cloud systems. We've had to see more collaboration between the infrastructure silos as well as the infrastructure and developer teams. And we need to see the same kind of collaboration between the business and the technology teams. The businesses best understand the business and the route to market, and the technology teams best understand the technology components to get there. So they need to work together more than ever in order to make this transition successful. Now, in order to deliver some of these compelling new services, we are seeing organizations look at new kinds of emerging technology solutions in order to deliver those kinds of services. So first being cloud, and we've mentioned cloud and the interest in cloud, but I want to step back and look at the fundamental assumptions of a public cloud platform. So when organizations are looking at lifting and shifting existing applications to a public cloud service as a way to increase the quality of that service, they have to step back and realize that the assumptions governing that platform are fundamentally different. You're no longer on dedicated infrastructure that maybe was a high-end infrastructure with high levels of throughput and performance. You're the only user of that, and you assume that that cluster is going to stay in the same place in your data set or adjacent to your storage environment. In a public cloud platform, you have to assume that all resources are shared. You are virtually isolated, but physically shared. And including the network, there's no necessary performance SLAs depending on your individual contract. And part of the value of public cloud services is you have global accessibility to the platform anywhere it could reside. But that individual applications weren't necessarily built to be run anywhere and could have static dependencies to individual components. So our general recommendation here is that to understand that not all applications are going to fit well into a public cloud platform. So for those serious about moving everything, you're going to have to step back and recognize that some applications may need to be completely redesigned in order to truly leverage the platform capabilities of a cloud service. On the customer engagement side, we are seeing an interest to transform, again, how businesses interact with their customers. This means trying to replace more transactional activities with more interactions over time and really an engagement experience versus just a one-time purchase. And in order to do that, businesses need to start connecting those experiences across channels, across individual moments and interactions, and really driven by understanding the customer journey through analytics and really being able to customize any individual experience based on that knowledge. And that could also mean pulling in external information to really extend those experiences regardless of where the customer is and what they're doing. And that really points to fundamentally new kinds of infrastructure capabilities to support these activities. More distributed infrastructure to support the customer or transaction or interaction anywhere, not just potentially at the register. It could be distributed throughout the store. It could be distributed throughout other stores and other environments. More data sources, more information about the customer means more stringent policies around data management and data privacy, especially in other countries where privacy requirements are different than in other countries. So understanding what those nuances are and designing a system that can solve all of those requirements. And being able to integrate into external solutions potentially means looking at other integration mechanisms that don't break your current security architecture, potentially integrating into other platforms, but also other data sources in order to extend this view of the customer. All of these activities point to an increased use of different kinds of technology components and increasingly distributed systems. So from an infrastructure management perspective, this really calls the need for increased abstraction and software definition throughout all layers of the infrastructure stack. And this is ideally meant to ease both the management challenge, but as well as increase the consistency at the developer level in terms of how they procure and access resources, as well as the experience at the end user level. How do you maintain performance regardless of what infrastructure resource this is sitting on, what kind of service and mechanism this is being delivered through, and how do you connect those experiences so that you as the owner of that experience can truly understand what is impacting performance at any point in the life cycle or the infrastructure stack. And unfortunately, this is only going to get more complex. With IoT getting a lot of money and interest on the horizon, we see a whole new bevy of infrastructure components and technology resources that might not look like traditional data center components, but they're going to have compute and storage resources. They're going to need to be on your network. They're going to need to be secured. And they're going to need to be managed in a more holistic fashion than ever before. So focusing now on how to manage an increasingly distributed and heterogeneous environment will put you in a position to start to manage the unforeseen challenges that IoT could bring into your existing systems. And at the end of the day, each individual customer is coming to your organization for a specific service, and they expect that service to be always on, always available, regardless of what it's being deployed from, how it's getting and routed to their individual device. And recognizing this previous story, there could be a multitude of components that sit below any particular service. And this demand for always on, always available services is really changing the attitude from disaster recovery to more of a mindset around resiliency. Even the term disaster recovery it feels reactive and slow. There's a disaster and then you need some time to recover. And that time, that downtime, is becoming a huge expense and a potential loss of revenue, loss of customer anytime that service is not available. And it's not just catastrophic events. These could be mundane issues, a power outage, or incorrect code launch into production. Anything could cause one of these outages. So the focus really needs to look at continuous availability. How do you embed resiliency individual service? And how do you move from a more reactive policy to proactive, maybe by changing the way that the process works, or maybe architecting the application to be resilient by design. Even the recovery time objectives are shrinking from days to hours, and even now to minutes, in order to deliver that always on, always available expectation. And that expectation is really going to be the driver of the competitive nature of the service. If you can, in fact, be always on, always available, regardless of internet traffic conditions, weather conditions, events that might change the individual performance on any given day, if you can deliver consistency throughout, then that can really bolster your brand and bolster your recognition from your individual customers. But in order to do that, you really need to expand the focus of what could potentially cause disruption. Again, it's not just weather events, but how all those mundane changes to your network, how you're delivering services, how you're managing capacity across those services, and how you're enforcing quality within your development lifecycle. And this focus really needs to extend beyond any individual component. A lot of traditional disaster recovery components are really focused on, say, the infrastructure or the storage environment, making sure you're replicating your data and making sure that you have a compatible compute resource to fail over and restart your infrastructure on. But dependability really extends beyond just those infrastructure components. And you have to think about it more holistically and say from the perspective of the end user, they are coming to you for a service, and that service needs to be not only always available, but performing well and of high quality. In order to deliver that, you have to design the system itself to be stable and always improve, especially as the dynamics change, as the requirements change, and as the threat landscape or the disruption landscape expands. And the third piece of this is really the support element, in that you always, not only you need the system to be available, but those that support the individual customer and support the service, support the system, need to be efficient and effective at any point in time as needed. Depending on the level of automation within your system, I'd imagine that the level of support that's provided by a human and provided by a system is going to change depending on your environment. But from the perspective of the end user, they don't see any of that. When they call your help desk, they want someone to be there who knows who they are, who can accurately diagnose their challenges and effectively provide them a solution. And that efficiency and effectiveness is also part of this overarching availability chain. From the perspective of the developers and service designers, we are seeing a new approach to designing and delivering services to be always on and always available. And these practices are evolving to deliver these services over these new kinds of platforms and heterogeneous distributed platforms. We see an interest in containers to increase the individual portability of an application. And you can look at this as flexibility of deployment or cost arbitrage, but also how about just moving a service around depending on performance challenges any given day? It gives you more flexibility to ensure consistency because the application is not static and dependent on one stack, but can be leveraged in multiple infrastructure environments. For DevOps, again, a lot of the focus is around increasing the application delivery cycle and developer productivity. But underneath that, it's also increasing the consistency of code quality and deployment. So automated tools that actually check the individual code to guarantee that it is in fact going to be production ready by the time it hits the shelf. And it's not just being able to increase the integrity of that code to increase the resiliency of the service as it's deployed, but the ability to also quickly correct it in the event of a failure. So this mentality of being able to fail fast requires a process like this in order to be agile enough to correct it on the fly. On the application architecture side, we are seeing a move away from traditional monolithic applications to microservices. This idea of breaking apart one overarching service running on one individual box is too limiting. Being able to break it apart into component services gives you not only more deployment flexibility of an individual component, you can even scale those components independently and potentially deploy those components in the environment that makes the most sense for them. This can inherently introduces more fine-tuned performance management, as well as embedding resiliency in the service itself. A loss of an individual component or VM now equates to only a loss in part of that service, or maybe even just capacity of the service if you've designed it to scale horizontally. And I want to close this idea with recognizing that regardless of what infrastructure capabilities you have today, there are multiple ways to think about designing for resiliency. And these architectures really gravitate around common attributes and ideas. So this idea of modularity, being able to maybe break an application into multiple component pieces to increase flexibility and scalability. But it's also around inherent duplication. Duplication has always been part of the resiliency process, but I want to change that idea to not just be duplication for redundancy, But how can you make use of that duplication? How can you either leverage that individual instance to support another region and have multiple instances running to support low latency user requirements to whatever geography you're doing business in? Or maybe looking at that disaster recovery environment and huge storage repository of all your historical data, and now see what you can learn from it. Can you run analytics on that environment and that's just sitting idle and gain more insight onto your existing services, onto any historical performance, onto any historical statistics, and be able to learn from that? Modularity also inherently can increase the diversity and deployment diversity, having components sitting in different VMs in different regions, and helping you to reduce your common risks. Having data centers deployed in multiple regions is not just to keep them far away and keep them separate from weather events, but it's also to increase the diversity of any individual risk. Are they on different floodplains? Are they on different grids? Are they on different support mechanisms? And really being able to have modularity to understand how you can increase the diversity so that no individual component is subject to all the same risks. Another core element is really data accessibility. And I think about data accessibility from two planes, from the application plane and the experience that the customer has with their information being stored and accurate within your system, but also the operational data that keeps everything up and running in the back end. On the front end, we need to make sure that we have complete visibility of performance and the service availability so that we know when there is an issue, we know where the issue is, and we continue to manage and remediate that in real time. And this requires analytics, this requires integration into multiple systems, and again, a very consistent and holistic picture of both the customer's experience as well as the operational and infrastructure components that support it. On the operational side, there's a lot of interest to continue to automate systems, and especially in the vein of resiliency, that means increasing the reactive time, maybe even reducing the reactive time to an almost near zero latency experience, and even potentially automatically stabilize things as they become unstable or performance degrades. But in order to do that, you need reliable operational data that you trust, as if there's the wrong kind of information that's fed into an automated system is a recipe for catastrophe, especially because now there's less and less humans involved in spotting any of those issues before they get launched or go into production. And what's central to all of these ideas is all about risk management. How are you ensuring security, integrity, and longevity of an individual system, of an individual service, across a variety of ever-changing risks on both the security side as well as the disruption? And understanding how each of these decisions should be weighed against the potential risks, and again, thinking about how do you diversify risk across not only your portfolio, but across components within an individual service. And at the end of the day, I want to recognize that every organization is going to be coming from a different set of infrastructure, coming from a different stage in transformation, and trying to solve a different need for their individual customer. And so I want to make sure that I mention that while there are all these new exciting services and capabilities, you need to step back and make sure that you are still meeting the needs of your stakeholders. Your customers are coming in with expectations, and you need to make sure that you are designing and implementing a service that delivers on your brand promise. So that concludes the section of my content today. So thank you again to the Quorum team for inviting me here today. I'm going to pass it off to Gabe now on the Quorum side to discuss how Quorum is working to solve some of these challenges for its customers.
Thanks very much, Sophia. That was actually really, really good. I apologize to everybody. Coincidentally, our template, the way we use the color scheme we use is almost identical to Forrester's, so purely coincidental. But yeah, thanks very much, Sophia. What we're going to talk about today is much of the same. I'm going to echo a lot of what Sophia went through. I'm just going to go down into a little more SME, SMB view of that, just from my experience talking to customers and what we do here at Quorum. Basically, we're going to talk a little bit about how our customer base and how users in general need to use growth from what they have today to a cloud or a more cloud environment, and what gaps there are to overcome there. We're also going to talk about uptime, because the expectations are really already set as far as your user base and who you have. And so we're going to talk about how to best meet those expectations and what to do when outages happen, because really they will happen. And it's just a matter of how you are set up to react to those. And then we'll talk about recovery methodologies that change with you, and that really have the security and the reliance of the app or the service and how that's accounted for. So the first thing we're doing is we're going to talk about growth. You know, as Sophia kind of alluded to, a lot of the move to the cloud is really a rip and replace mentality. And that's really expensive, especially for the small to medium business or the small to medium enterprise. And that methodology or that mentality is going to take time, because as she said, you know, there are applications that just aren't going to fit the cloud picture. And so how do you manage those? You know, when is the right time to upgrade those or change those or change your workflow? And so that a stepped approach and a real methodical approach is really what we're going to see the SME market do. Customers and their expectations are really always up. I use the analogy of dial tone. When you pick up your phone, your landline, you just expect dial tone. And in fact, you are shocked when you don't have dial tone. You must be in a hurricane or in a tornado or something, because it is just so fundamental to what we do with a phone that it's taken for granted nowadays. Well, that same mentality of always up and available is really moving itself in to our applications and our digital life. You know, with our iPhones and our cloud internet at home and everything, we expect services to be up and running, whether it's Netflix or Salesforce or, you know, my email. And that mentality is really pushing its way into even my local network and my availability. And so instant recovery, until you can get to resiliency, is really the realistic approach to address this demand that our customer base and our users have really fostered, because of the internet and because of this dial tone mentality that the cloud has offered to people. There are definitely gaps in getting from here to there. Those gaps are really based around the facts that you really have to address who owns the data. Google Drive, when they first came out, this quote was really brutal. You know, Google owns your data, and technically they could do whatever they want with it. Now, of course, they've put amendments to it and changed it over time, and it's definitely adjusted this mentality. But where your data sits, what country it's in, your data sovereignty, all of those things really play a factor in customers wanting to move to the cloud. They want to control that data, because that data is their digital bloodline. It is their business. Whether it's their email, whether it's their databases that hold their accounting system or whatever, they understand that data is the critical path to how they do business. And so where it sits and how it's owned becomes a reality. And like I alluded to before, outages are going to happen. You know, whether it's your Slack or your Office 365 or Apple or whatever, they've all hit the headlines for going down and having problems. And being able to protect that data, access that data, and use that data during these outages becomes one of the gaps that a lot of customers worry about in moving to cloud. Now, the benefit is, you know, let's be honest, the cloud is much more resilient than the mom and pop shop down the road that has the one server running small business server 2003. They're going to have a better chance of having that uptime when the fan goes out in the server and it overheats. So there is that reality to being in the cloud. Performance is almost always below what you could build yourself when you're dealing with the cloud. Sophia said it exactly. You are in a shared environment, and there are times where that shared environment will function exactly as you predict, but there are times when it won't. And not owning that performance is one of those barriers that a lot of customers they worry about. And so being able to get that data back is the other one. So, you've put it all out in the cloud, but if you want to change vendors or you want to do something, how do I get it back? How do I control doing that? If it were on my local server and I'm doing a forklift upgrade to a new platform or a new software, it's a process I can control. But when I'm dealing with a cloud vendor, I might be limited by their SLAs. I might be limited by their bandwidth allowances for me to pull data down versus upload. There's costs and there's processes involved. And so understanding those and knowing what your risks are becomes one of the gaps that I see a lot of our small businesses facing when looking at cloud services. And I talk to customers day in and day out, and one of the biggest hurdles that I have is really they want to use the cloud. They love the idea of less management, less overhead, not having to control it. But at the same time, they have this fear of, but I want to control it. So it's a very double-sided coin for a lot of the users that I speak with. And so going through this, that is the main gap that they face. So we really focus on the uptime of what I have today, right? Because it's an iterative approach. If I want to put it into a resilient cloud service, but my application's not cloud ready, what do I do? And so she said there's 19% movement to the public cloud in 2018. Well, that means 81% is not in the public cloud. So being able to control and recover that data and have it available becomes the path of least resistance, because I've got to give that already set expectation of always up. So if I'm the IT manager and I'm looking at it going, my customer always expects my mail to be up, but I only have this single server, and if I lose the hard drives in it, I'm not gonna be up. My backup recovery process isn't there. And so being able to give that uptime in minutes or uptime in seconds recovery becomes the process that I have to do. And in order to define whether it's seconds or minutes or hours, I really need to understand the business criticality of that application, that service, that piece of digital knowledge that I have. And so for some things, it might be backup to tape. For many, it's going to be DR as a service, or it's going to be high availability so that machine is ready to go the moment I need it. And of course, if you're the big enterprise, you're the IBMs of the world or the AT&Ts, you're going to have those, the clustering and the fully replicated data centers and full-time, hardware ready to go for those disasters. But in reality, every customer I've ever spoken with just says they're not that size. They're not ready for that. They need something that's in between the replicated data center and the tape backup that's in my IT manager's trunk or whatever it is. And so local infrastructure really wasn't designed to meet these demands. And so it's all a matter of taking that mentality and applying it to high availability and recovery. So not everything is cloud ready. I meet with customers every day that have either in-house built applications or they have their SQL server that's so impacted, whether it's Oracle or SQL or MySQL or whatever, but it's so impacted and so active that if they even for a moment considered putting that in a shared platform, a shared infrastructure in the cloud, they would just, their business would come to a screeching halt. And so they have it internal and they want to have that recovery capability. And so whether it's, having a high availability solution that's available to them or a disaster recovery solution, they need to have that. And so as they put in these cloud expectations, this is where disaster recovery as a service really kind of fits into that model. Because what you do is you say, okay, I don't want to pay for replicated hardware. However, if I could find a service that could have my recovered data for me and be able to spin up on demand, I might have something as that stopgap until I could fix my local stuff. So if I do have a disaster, my building catches on fire or like the floods that we've been having all over the world lately, disaster recovery as a service becomes a way to have that stuff separate and still leverage cloud infrastructure to give me my local demand. And that's really what I see a lot of customers focused on, because let's be honest, having a tape backup that takes hours and hours and hours to recover your server is just unacceptable in today's day and time. So what you need to do is you need to have a solution in this that is agnostic, right? A lot of services over the next 5 years for you are going to change to cloud-based. A lot of applications, a lot of expectations for your things are going to move to a private cloud, public cloud model that Sophia was talking about earlier. I mean, we're just seeing it especially for the rip and replace type mentalities. You have accounting. Accounting is a very general task that every company does. It doesn't necessarily need to be a specific application to my company. I could definitely put that in the cloud, and that's where you see the Salesforces and the NetSuites and all of those type of applications that are flourishing because every company needs them, and so they're ideally suited to live in the cloud. But you have that specific thing to manufacture my server or my widget, whatever it is that I create, might not be best suited for the cloud, and so being able to recover that quickly becomes critical to my business. And that's where we see a lot of our customers come to us and talk about that. As we go to the next slide here, we're going to talk about recovery. So this is the driver for most of the things that we have. Recovery solutions should be agnostic. And what I mean by that is, as my environment changes, because as we've seen over the last 5 years, and we project that we're going to see definitely over the next 5 years, services are breaking down. They're becoming, as Sophia targeted, they're becoming microservices. They're becoming easily small components that can be picked up and placed almost anywhere and serve their function. And as that environment changes for our customer base, the recovery solution you have, or the resiliency that you're looking to build, should be agnostic to that change. So it should be able to adapt as you change. And you should be able to protect what you have now and tomorrow, right? As those services change, you should have a solution in place that's not going to tie you into the platform that you're on. So any solution that you have that's based on what your hardware is going to struggle in this new environment. Any solution you have that's based on an outdated application that you're going to be changing is going to be hard to support. And so you should put in something that's agnostic and able to change and leverage with you. Instant recovery should fit your physical servers, your virtual servers. If you're on an infrastructure as a platform living in AWS or Azure or whatever, your instant recovery mechanisms should be agnostic to that and be able to work no matter where it is. She talked about a lot of the concern that people have with putting stuff in the cloud, because unless you're specific about the cloud service you're using, it might not be already resilient. It might not be geographically dispersed. If you bought the cheap option, quote unquote, when you built your server in AWS, it's sitting in a single data center on a single piece of hardware. So if it goes down, you're going to face problems. Whereas if you paid for the more expensive solution, you might have resiliency and geographical dispersion. A lot of people don't, but they think they do because it's in the cloud. And so you want to make sure of that if you're going to put it in infrastructure as a platform service arena. A recovery solution like what Quorum offers gives you a stopgap, or gives you a flexibility where whether it's local or in the cloud or whatever, you can still protect it, you can still recover it. And really at the end of the day, that's what you're looking for, is the ability to recover no matter where it is. Protecting your public cloud, not living in the public cloud. What I mean by that is a lot of our customers, the first thing they say is, well, can I take the data that I'm protecting and can I put it in, AWS's cold storage? And I'm like, well, sure you can. You can't run it from there. It's no good to you there other than file level recovery. And what I see most customers need is that ability to recover everything. So putting it in the public cloud becomes an expensive solution if you're expecting AWS and compute to go along with it. So what you really want to do is you want to put it into the public cloud if it's data and it's cheap, but you really want a private cloud or a bespoke solution for your disaster recovery if it's not, right? If you need to be able to run that whole server, your SQL server, your mail server, or whatever it might be, you need a solution that's going to be able to bring it up and run it when you need to run it. And a lot of the public cloud solutions don't give that flexibility at this state, unless it is a cloud server that already has the resiliency built in. And so when you're looking at your 81% of your internal servers, they don't have that. So you really want to take an approach of a solution that will give you that flexibility. Oops, sorry, I went too far. Last thing is the recovery drivers. As we've said several times in this webinar, the recovery drivers are the expectations are 24/7, right? They're expecting dial tone every single time they use the application, they use the service, they use whatever it is to get to that digital data. And if you're going to provide that, you really need a solution that's going to be able to meet that demand. A lot of our customers have regulatory requirements, whether it be HIPAA or PCI or FDIC or whatever the requirements are for you. Those are the drivers to give you that uptime expectation beyond what your customers have, because really the regulatory body is saying, hey, your customer base expects this. A good example, I came from the banking industry, and you learn all of these little rules about the banking industry that you take for granted as the customer or the user of the bank. Things like they can't be down for 3 days in a row. That's just the bank regulatory requirement in the United States. And you think, wow, you know, that does make sense. Like when you have those 3-day holidays, there's always that 4th day that they're open. So over Thanksgiving, that Friday they're open. It's those little things that start to add up. And so when you talk about their servers and you talk about their ability to recover and their regulatory requirements, if they went down, if they lost their server farm and were down for multiple days, the FDIC can come in and close them. And so being able to have that capability to recover is not just a want, it's a mandated. And so you really need to have those regulatory requirements. For a lot of customers, it's the cost of downtime. You know, if you're a retail market or you're a manufacturing facility, you just can't afford to not have your ability to build your widget or transact the sale that you're making. So that cost of downtime becomes a motivating factor. And last but not least is definitely risk, whether it's risk to your name brand, as Sophia talked about earlier, or it's your risk to the security of your company. Having that ability to recover, whether it's local or in the cloud, is really the driving factor. And so as we see customers really, the trend moving towards cloud and moving towards this dispersed shared model to give us a resilient future, there's a long way to go between what I have today and getting there. And so being able to put in solutions that give you that flexibility to change over time and give you the uptime demands that your customer base has become the critical moving factor as you go forward. Really, that's all the stuff that I wanted to cover. I'm going to give it back over to Darren and open it up for questions.
Great. Thank you, Gabe. I appreciate that. As we said at the beginning of the presentation, please feel free to type your questions into the console. I have had some questions come in, so we will take as many as we can at this time. It looks like, sorry about that, let me get rid of some things here. Okay, so let's start with this one for Sophia. Where are organizations most challenged in their resiliency efforts? I think you and Gabe both had good points on both sides of this question, so I want to toss that over to you first.
Yeah, I think one of the biggest issue with existing programs is the lack of testing and throughout process testing across the entire life cycle of recovery. You might have all the tech in place, you might have all the solutions in place. When it comes to an actual disaster, an actual requirement to fail over, often without the prerequisite amount of testing, organizations fall down when it comes to actually restoring this appropriately. So I do see that continuing to be a residing challenge across disaster recovery and business continuity programs, regardless of what technology they're using. On the other side of it, I think I want to reiterate a couple points that Gabe made in his presentation, is that there is no consistency today on what's actually included in existing cloud services. Some of them are, in fact, resilient. So there are instance types on Azure that give you geo-clustering as part of the instance type, but that's not the de facto standard. Most are not, and so you still need to apply the same kind of resiliency mechanisms that you were doing before, or adapt them for public cloud platforms to guarantee that this service is going to be always on and always available. And that changes depending on the provider as well as the cloud delivery model. Software as a service is notorious for not offering resilient services. They have their platform, and if you delete data, then they will charge you an arm and a leg in order to recover that. So the directive is on your organization to ensure you've procured a solution that can back up, or you've designed your service to be resilient on that individual platform.
Great. Okay. Thank you for that. Okay, so Sophia, another one for you, and then Gabe, I'll invite you to take a go at this as well. So, how do resilient approaches change as customers adopt cloud solutions? So, how do things change over time? What do you see?
Yeah, so I see organizations, actually I think one of the fun facts to mention here is a lot of initial public cloud interest was directed around disaster recovery. It is a fundamentally temporary workload and made a lot of sense to be deployed in a public cloud platform. So there's a lot of interest initially of leveraging cloud as an element of resiliency, but as per the last answer, there's a lot of inconsistency in which individual platforms provide. So customers have had to find that they either need multiple solutions or to vet that any individual recovery or resiliency solution can apply to whichever platform they're using from both the SaaS side, the infrastructure service side, and existing dedicated infrastructure on premises. Additionally, we are seeing more interest from the development side to design solutions and applications that are inherently resilient by design and process. So that idea of microservices, container services, and ways to reduce dependency on an individual piece of hardware or location and embed more resiliency in an individual service itself.
Great. Gabe, anything to add on to that? Do you want to add any additional thoughts there?
Yeah, a couple of things. The first thing is when you're talking about being able to recover and resiliency and in your platform and where you are, I kind of go back and put these two questions together because there's really a set of answers that fits both. And really what it comes down to is recovery is really motivated by the business. So if your business needs a recovery solution that is 24/7, then your adoption of cloud is going to really focus on giving a resiliency that has 24/7. So you might not use the de facto standard of Azure. You might really understand that and make sure you have geolocated, fully redundant servers set up. But at the same time, because 81% of your stuff is still internal, paying for that kind of redundancy becomes the critical path. So as time goes on, you'll see a lot of the bulk services going to the cloud, but you'll see a lot of the customized bespoke services staying in-house. And what you're going to see is exactly what Sophia said, the ability to test it and the ability to get the business to agree with your RTOs, your redundant, your timelines is really where a lot of customers struggle. because they'll say, oh, I can have the server up in 8 hours, but you go to the business and they say, wait, I need this server up yesterday. And that's a breakdown that I see a lot of people face, is the IT doesn't match the business need. And that's where they struggle more than any of the technology that they use, in all honesty.
Okay. All right. Great. Thanks for that. I think, okay, so IoT. So Sophia, let's start with you. So this came up, you mentioned this, IoT and other emerging technologies. You sort of raised this idea that there's a lot of these on the horizon. What can people do to sort of prepare for their eventual arrival? What advice do you give people who are thinking about this, trying to get ready for it, when we really don't know what's going to happen?
Yeah, and I think even more concerning is, unlike infrastructure components within a data center, you can't really duplicate these environments. They are in a retail store or they're in a manufacturing floor, and there is no option to fail to something else. So resiliency efforts need to really look more at designing stability within the system itself. And luckily, these are the same mechanisms to do that are things you're already working on in your infrastructure environment. So how are you increasing abstraction to be able to embed automation in the system so that it can either correct itself or have flexibility to make nothing dependent on the same thing, and sort of diversify any single point of failure within your architecture. And a lot of this is going to have to be uniquely set up for the environment. I think one of the biggest challenges with IoT deployments now is that they're so inconsistent. Every component is slightly different. Every vendor is slightly different, meaning that every architecture is going to be slightly different. So how do you inherently embed resiliency into this design? And a key part of that is also data management. So I mentioned this earlier as being critical to resiliency efforts, regardless of the system or what level of the stack you're designing this. So having data not only available and secure, but integrity, it has to be there, especially when you're talking about machine data that has to rely on other data in the system in order to maintain operations.
Okay. Great. Gabe, any thoughts on that one? How to prepare for some of these new IoT challenges?
Really, what Sophia said is really spot on. I mean, the real limiting factor in IoT, if you're talking about resiliency and uptime, is the fact that they are dispersed, and you're not going to have two of everything. It just doesn't financially or economically make sense, and so you really have to rely on the vendor that's producing such technology to make sure that it's not a single point of failure in the overall design of the workflow or whatever you're using for.
Okay. Okay. We're getting close to time here. I think we've got one last question, and I'll throw this out to both of you. And unfortunately, I think it's a pretty common situation. So I think this is a good one to kind of end with and sort of wrap up with. But what if my applications just don't work in the cloud? Gabe, I know you touched on this specifically, but I'd be interested to hear guidance from each of you on what to do in that particular case. So Gabe, why don't we start with you, and then we'll give Sophia kind of the last word on this.
Sure. So if your application is not just ever going to be cloud ready, right? It's a bespoke application. It's set up to be either highly performant or it has demands where the cloud just doesn't make the model right. What you want to put in place is a recovery platform or a resiliency, like whether it's replicated or whatever, that meets the demand of your business. And that's really where your focus and your attention has to be. So if you're in a platform that it has to be zero downtime, 5 nines up, you really need to make sure it's replicated and it's resilient, and it has 2 pieces of hardware for everything it's doing, and it has 2 connections to the internet. It has 2 of everything, so that you have those 5 nines. Should any one node go down, you have a recovery. For most people, it's not that level of uptime, and a recovery platform like what Quorum does is ideally suited to give you the up in minutes or the one-click recovery that you would have.
Yeah, but I completely agree with Gabe on this. I think there are always going to be services that don't make sense to run in a cloud environment, especially for any legacy environment, whether or not that's based on compliance, latency restrictions, or just the pure cost to move it to another system. It might not make sense to move it and just eventually decommission and replace it with something that's more flexible. But in the meantime, you still have to mix and match the right type of resiliency solution for that scenario. So I completely agree with his answer here, and I think that the next piece to that is also understanding that while there might be individual applications that do not move, you still have to weigh the interaction of those applications with other core systems that might be more flexible. So the interdependencies between those applications could impact the performance of both components if you start to stretch them apart. So as part of your broader cloud roadmap, you're going to start to identify those things that really just cannot move. So understanding the implication of tearing those apart from the rest of the environment that is moving, and knowing that even if they stay on premises, you might still have to reconfigure the overarching architecture of that service to not be impacted by performance challenges as you start to stretch these systems further and further apart.
Great. Excellent advice. Thank you so much. All right. Well, ladies and gentlemen, thank you very much for your time today. I want to thank both of our guest speakers for wonderful presentations, great advice, practical advice on how we can get to that next level of resiliency. As I said at the top of the call, we will be sending out links to the recordings. So if you would like to share the webcast with any of your colleagues, that will be arriving via email very soon. I want to thank you for your time today. Have a great day. Thank you. Bye-bye.